So my first statement says, two polygons are congruent if their corresponding angles are congruent. And the links that are corresponding are also congruent. So if everything is congruent to each other, it's got to be congruent figures. Let's go ahead and curly bracket and put a star on this. I will read this to yourself about 10 times before the quiz on Tuesday. Second statement, two polygons are similar if the corresponding angles are congruent. So step number 1, angles got to be congruent. And then step number 2, the lengths must be proportional. Because when they're proportional, they have the same ratio, the same rate, so therefore it's got to be similar polygon. So let's worry about what the similar polygon or similar notation is. This single wave means similar. So if you ever see that on the quiz or test, it means the figures are similar to each other. So example number 1. Frank, let's read the instruction.
Identify the pairs of congruent angles and corresponding sides, then write a similarity statement.
So we write a similarity statement after. So the first thing that we have to do is, let's see if the sides are, or angles are congruent first. We have a 90 and a 90. Is that the same?
Yes.
63 and 27, is that the same? No, but then I know up here is 27 by the triangle sum theorem. Down here we have 63. So I have 27 is congruent to 27. 63 is the same as 63. Yeah. So therefore we know it is similar according to the angles for now, right? And then we need to go ahead and see our ratios. On the ratios, I think I'm going to go to highlight the longer leg on both of them. And my longer leg on both of them is opposite of 63. So if I have 2 to 1, that's basically 2. So I'm expecting 2 on every single one of them. Let's compare the shorter leg. Here's my short leg opposite of 27. So if I compare 1 to 0.5, what does that simplify to? 2. And then my hypotenuse, 2.2 to 1.1, that simplifies to what? 2. So I know they are proportional. So here's our similarity statement that I'm going to write down here. Triangle, MNO, is similar to triangle. Now, the order has to be consistent. If I start from M to the other hypotenuse to the short leg, what must the other order be? T and QR. Very good. So make sure you're being consistent with the order. So let's put a check mark on the bottom. It says all the angles are congruent. That's true. Were all the sides proportional? Yes, they were. Now, the 2 that we found, when we simplify the sides, that's actually called a scale factor. And our scale factor for geometry is denoted by K. K is scale factor. So with the partner, let's decide on, is the following on example number 2 similar? Go. Talk to your neighbor. Make sure you analyze the angles first. All right, give me a fist. If it is similar, give me a thumbs up. If it is not, give me a thumbs down. Okay? I see all saying it is similar. First one is, are the angles congruent? Yes, because rectangles all have 90 degrees anyways, right? And then if I compare the sides, 64 and 96, they both have 3/2, meaning they are proportional. And keep in mind, 3/2 is a scale factor for this figure. Okay, example number 3, let's analyze that one together. When you're ready, let's go to example number 3. So on example number 3, let's see what all I have.
What? I know. Hold on.
Let's get it after the lesson. Yeah? All right. So this one, we're also determining if they are similar. So let's look at the angles first. Here I have an isosceles triangle. Do we see that? So if I know these two sides are congruent, these two angles must be congruent. So if I take 180 minus 36, isn't that 144? What is 144 divided by 2? 72, okay. And just by that, are they even similar? Nope. And we have to reason, it's because all corresponding angles must be congruent for it to be similar. And it's not. What is the name of the figure on the bottom after that? It's not a quadrilateral, it's not a triangle, it is a pentagon. All right, for the pentagon it says they are similar. So we are allowed to say, here's my wave. They are similar to each other. Now, it doesn't matter where you start, but you have to be consistent on the second image. Let's say I start at G. And I go in the rotation from G to I, H, X, J. So G, I, H, X, J is similar to. Which angle is corresponding to G? Okay. So since I went from G to I, do I go from K to M or K to N? K to M. So let's go in that rotation. K, M, L, Y, N. You're just going in circles. Let's find a scale factor. It really doesn't matter which one you start with on the scale factor, but I will make sure the corresponding parts are congruent. So, highlight HX. What side is corresponding to HX on the next image? YL. And that is enough for me to say, well, there's my scale factor. So my scale factor on this one is 4 to 6, which when I simplify, we get 2 to 3. So then we have a problem here. My answer could be 2/3. Or, depending on which direction we're going, my answer could also be 3/2. Because we're going from left to right, and the right is where we're ending with. It is a bigger image, correct? Which is a bigger fraction. 3/2. So we know our scale factor is 3/2. Put a big star on example B. So let's find JX then. On JX, let's call that, what letter wasn't used? W maybe? And I'm going to highlight W. I'm also going to highlight the corresponding part. What side is corresponding to W? YN. So let's see if we can do a proportion. I'm going to say W/12. Now when we are doing proportions, there's many ways to go about this one. So if you have a different fraction than mine, it's okay. So if I go from W/12, I need 4 over what? 4/6. And when I cross multiply, we get W is equal to 8. So I'm going to write 8 on this one. And I'm also going to go and show you another way. If you don't want to write the next piece, you don't have to. Meaning if you just want to look, it's okay. Y'all ready? Okay. W is similar side to 12, correct? So I'm going to write 12. And then I'm going to ask myself, my W is from a smaller image. Which is my smaller fraction? 2/3, okay. If you type that in, that is also 8. So let's say you forget about the proportion part, but you do know the scale factor. Go ahead and use that if you want, because we'll get the exact same answer. Is everyone good with that? Okay? So there's not one way to find all the answers for this one. Okay, with the partner, let's go ahead and do D and E. Go. Can you add all the sides? Did we get 38 and 57? When you simplify 38 and 57, you should get 2 to what? 2 to 3? Look what's interesting about this. Do you remember 2 to 3 from the previous one? They are directly related. Okay? So let's write out the theorem. If two polygons are similar, then the ratio of their perimeter that we just discovered is equal to the scale factor. Because we had our scale factor and we had the ratio of the perimeter. They are equivalent. Everyone good with that? Okay? So here's a question for you. Jet, let's read the next one on the bottom right here. What would
be the scale factor of two congruent polygons?
So if I have an item, and exactly the same item, what's the scale factor between these two? 1. It's 1. Because everything about it is identical. All right, on example number 5, I'm going to have y'all partner up, but I'm going to clarify something. I want you to circle this equal sign, and then circle the congruent sign. When you see equal, that means your answer must be a number. When you see congruent to, you're looking for a corresponding part. As in, what's another angle that is congruent to M? Angle A, angle B, and so on. All right, partner up. I'm going to give you about a minute. Go. I should hear more talking and discussing.
Wait, ML is equal to.
Well, we have to find the ratio. Where did I say? It's 3 over 2.
Yeah. Do you remember your number?
Yankton.
Okay. You don't forget. You actually went for that other item. I see you.
I wasn't thinking about it. That's so weird. Okay, we gotta get punched in the face. What? You do.
Did y'all realize it's not a triangle, it's a quadrilateral? Yes. So the inside of the angle must be how many? 360.
I'm not making fun. I'm not making fun. Me and Horace go way back. It's literally just a thing on my shirt.
How do I? Have you got what?
No, yes. Right? Why does it matter what I wear? It doesn't.
This is the smaller. This is the smaller one first.
Right. What's the end result is WXYZ. The end result is bigger, so the fraction has to be bigger.
Oh,
So it's either 3/2 or 2/3. My end result is bigger.
okay.
Okay?
The end
It's
result
not
the
always
bigger
left to
one?
right.
The end result always the bigger one?
Not always. They'll actually say it on the question.
Is it just the same?
So if I reverse
Oh,
it,
the
it'll
end
be
result.
smaller.
Okay.
I'm definitely gonna get rejected.
Okay, I'm gonna move on to the next page in about 10 seconds.
No.
No.
There are no words I'm writing.
Yes, okay. Now, how is it six?
Question?
How do I figure out what 8?
Which one?
3 times 9 times 2 is 6.
Oh, so it's 2 out of 3. I have that.
There you go.
Because you're going to the smaller figure.
So we need a smaller fraction. Thank you, Frank. Annika?
Where does the K come from for part I?
Part I. K came from, it says, from LPM or NM to WXYZ. That's our end result. My end result is bigger, so I need the bigger fraction.
Yeah, but like,
But if I went the other way around, I'll get the other one.
why is there a K?
K is a scale factor. It's just a ratio. All right, last question, number 6. Everyone flip to number 6. Okay, Shayna, let's read number 6, please.
The triangles below are similar. Solve for the variable and the missing side.
So they are similar, so let's use our symbolic notation. Because we're looking for the variable, I know I have to use the one with the variable, which corresponds to 49. Now, I can choose to use 63 or 35. Do we want bigger number? If you had an option, you would not use a bigger number. You can. We'll get the exact same answer. So if I were to do by proportion, how many ways can I write the proportion again? 4. 4 ways. You can rotate it in 4 different ways. I like to start with the variable. That's just my preference. 6x minus 7 over. I can write 25 next or 49. What do you guys want? Should I write 49 on the bottom or 25? They're both correct. 25. So if I went from my circle to the square, I need to go from my circle to the square, meaning 49 over, what's the other number? 35. Okay, let's then cross multiply. When I cross multiply, we have, what do I have? 35. Actually, could I make this number even smaller? Is there a way to like divide or simplify the fraction on the right? 7. So I could keep the left side since I can't really factor out the one with the variable. So 49 divided by 7 is how many? 7, okay. And then 35 is going to give me 5. Then let's cross multiply. You don't have to do this since you have a calculator, but in case that goes away, right? 7 times 25, how many is that?
175.
175? Can somebody confirm?
Yeah.
I confirm.
175. All right, there's two ways to go about this step. I can either distribute or I can divide it by 5. What's gonna make it even better? Divided by 5. If you want to distribute, go for it. So we have 6x minus 7 is equal to, how many is 175 divided by 5? 35, is that right? Okay. And then we have 6x. When I add 7 on both sides, we get 42. And when I divide it by 6 on both sides, we get 7.